The next problem in our sort of random adventure through question number 10 is going to be question D, because that one is somewhat related to question letter E, which is also tangentially related eventually to letter I. So I want to just kind of break up these little things into chunks in the hopes that we can build one abstract idea at a time rather than laying it all on really thick at the beginning and letting the idea build a little bit as the concept makes more sense and settles in. In question letter D, we're going to, once again, notice that it's a sum and use the rule that we saw on page 2 that says that we are totally allowed to break up an integral that contains a sum into two completely separate integrals. That strategy really comes in handy often, and you can tell we did the same thing in letter A and it paid off there, so it's probably the right move in letter D as well. I'm going to break this again into two integrals, the integral from -2 to 5 of g of x dx plus the integral from -2 to 5 of 2 dx. Now, again, I need to kind of think about where I've seen this information before and what I can do with it. So I'm going to start fact-finding a little bit. G of x looks familiar because they gave me something about g of x in the original directions, and I'll continue with my color coding scheme here. The green for G, of course, means that we have a direct substitution that can be made. The integral from -2 to 5 of g of x dx, that's exactly what they gave me here, and that whole quantity must be a 5. Simple, simple. That, feeling good about. Now the second part, I don't even have a highlighter for. The second part I'm looking at going, ooh, 2. Didn't see a 2 anywhere, uh-oh. But this is where having that flexibility of mind I mentioned in a previous video can really come in handy. 2 is not a function that they've told us about in this abstract area context. We don't know anything about the area of 2. We know about the area of f, we know about the area of g, we know about the area of h. We don't know the area of 2. So change your translation. We don't know the area of 2, but do we know other synonyms for the integral of 2? Because we do. We know the antiderivative of 2. Area, antiderivative, synonymous, same thing. So I'm not going to think about this as an area problem because I can't. They didn't tell me anything to find an area of. I'm going to think of 2 as an antiderivative problem instead. And I'll do a little bit of scratch work or side work here so you can see my logic. I'm going to think of this problem as a basic antiderivative question. Not really as an area problem at all, as an actual antiderivative, almost as if it was like on a quiz from the previous chapter. If I think about the antiderivative of 2, that would mean that 2 is a derivative of something, so the antiderivative of 2 would be 2x. The implicit notation tells me that the variable is x, so I know that. Now, this is not a plus c situation, it's a definite integral because I can evaluate it at 5 and at -2. And I'm going to do the same thing I've always done. Plug in 5, plug in -2, subtract, and get that value. So if I plug in 2 times 5 would be 10, minus, I'll plug in again, 2 times -2 would be -4. 10 minus -4 becomes 10 plus 4. So the value of that integral must be 14. I have no context for this whatsoever. I have no idea what 14 has to do with any of the facts that they gave me in the original question or any of the areas, and I don't care. It wasn't supposed to have anything to do with those numbers. 14 was supposed to kind of come out of nowhere. But let's see if we can go from here. We know that that substitution is going to give us a value of 14. We know that integral is going to add up to 14. Sadly unhighlighted because it has no context in the original highlights, but what ifs. So I have my 5 from the first integral plus my 14 from the next integral. And since we know that we're just supposed to add these two numbers together, and they're very easy to add, 5 plus 14 is 19. Again, I wish we had some way of checking. It's always so satisfying to look at a Desmos or to look at something and to say, ah, that makes sense, that answer makes total sense to me. We don't have that security with these. We don't really know what 19 is supposed to represent. An area to a picture we can't tell, apparently. So it's a little frustrating to not know if 19 is an answer, let alone a right answer. But I'm going to reassure you that you can use the answer key, and 19 really is the right answer. So while these problems are context free, you certainly can still check your answers and have some security that if you got the answer by just going through the motions, you're doing everything that you need to do. There's no deeper meaning to that 19 that you're supposed to somehow parse. Now, if you figured out logically why 19 works and it makes sense to you, try letter E. Because letter E is very similar. It's using the f of x function instead of g. It's got a -6 instead of a 2, but it's the same idea. So between now and the next video, try letter E, check your answer, make sure you can kind of go through those motions, and then we'll try to kind of abstract in a different direction and continue to build your ideas.